Why does a dielectric increase capacitance of a capacitor? A capacitor is just two metal plates, right? You bring them close to each other, and it's designed that way in order to basically taunt each charge with the opposite charge really, really close by, so it's attracted, right? That's why the capacitance increases when you decrease the separation. If you put a dielectric material in there, you have a material that can be polarized. That's the important part. Like, you either have something that's completely symmetric, and then when you exert a field on it, it becomes unbalanced. Or you start with a substance that's already polarized but randomly oriented, and then when you exert the field, they all line up. So that's two different ways to turn unpolarized into polarized. What that does for capacitance is, if you put the plates there with the dielectric in between and you start to charge it up, these polarize, and so all the charges, it's like this plus and this minus cancel, this plus this minus cancel, and in effect you're left with a bunch of negatives right here and a bunch of positives right here. So it's as if you have made that gap dramatically smaller. Okay, why don't we just make the gap smaller? Why don't we push the plates closer together? Because then you're going to get a spark, right? You'll short out the capacitor and it won't work. A dielectric, remember, has to be an insulator. If you put a conductor in there, you've broken the capacitor. So putting the dielectric and putting on the charge polarizes it so that it feels as if there's an even narrower gap. The charges are pulled more strongly, and you can fit more charge on there for the same amount of voltage. The dielectric constant is the multiplier for the capacitance.